Hello. Let's begin. So, welcome to attend the BIER session in IETF 122. Please make sure you are in the right room. And our chair are remote attending the meeting. So, our chair, Tony. He must mute himself. Right.
Hey everyone. No, you both chair. I'm just standing by. Greg should be also online. But it's all to you. Control the crowd. Good luck.
Well, apparently we don't have enough seats down below, so I came up here as well.
So, anyone wants to take the meetings? So, okay, let's begin. So please note that this session has been recorded, and this is a not well, the not really well. And the meeting tips for IETF 122, you must use the medical to sign in, and you can use the medical light to join the mic queue and participate in showing the hands. And please make sure to sign into the session by the data tracker or the QR code in this session. And for the remote participants, please make sure your audio and video are off unless you are you want to present anything. Yeah, and please use the headset. So this is the resources for the meeting, and you can find its minutes link, and please help us to do the minutes take. And this is our agenda today, and you can see we have many discussions about the interop test, and we also have some FR discussion. Before that, we have the overlay discussed here. If you have any comments and questions, please tell us. And let's see the working group document status. And we have 2 drafts in RC editor queue, and we also have a draft in ISG status. And we collected all the working group drafts that are in or past the working group last call. So there are so many drafts here, and please find which step have you lost in the process, and we'd like to move some key documents to ISG at first after some important steps has been done. Yeah. So Greg, any comments?
Okay, I think that, okay, first of all, thank you for the summary. It's very helpful. Second, I agree that it will be very helpful to move OEM requirements because that other solutions, OEM solutions like PING and BFD and performance measurement OEM. And actually, we do have another document that I'm responsible for. It's MTU Discovery, BIER MTU Discovery. It's just expired. I will refresh it. Yes. So, as you can see, many documents OEM related in BIER are ready for next step. So if the OEM requirements and other shepherds can do the write-up.
So please call the shepherd.
Yes, I'm committed. to do the work. So if there are any comments, any questions from the shepherds, please let me know. So I'm looking at Human, so I don't know if he feels it. Yes.
Yeah, OM requirements. Seems like we just lack the shepherd write-up. Yeah, human.
No. Okay, there is a formal write-up that needs to be accessible. No, again, maybe you need some help from the chairs, because basically, usually the write-up is answer to formal 15 questions, but it needs to be, yeah, it's submitted through tool. Okay, so yes, and let me know if you have any questions. Okay, yes, thank you. So,
Okay.
standing by.
And also, we'd like to move some key documents at first to ISG progress, because they may block many other documents. So just like non-MPRS encoding and OSPF v3 extensions. So yeah, that's all. Please tell us if there is some missing or something mistaked. Okay. So is there any other comments or questions about the working group document status? So if there is none, we'd like to move to the next presentation. Human. Sorry. Okay, I can't control it. Sorry. We must learn how to control it every time. The first pin.
Okay, next slide, please. Yeah, again, the background here, just very brief summary. We are seeing that some of the vendors out there, they are trying to simplify their network, what they call a lean core or a lean network. And they got the legacy multicast protocols in there, and they are trying to remove the legacy multicast protocols in a way from that part of the network so it doesn't affect the other part of the network. As an example, if you're removing PIM from the core of the network, you want to make sure that you are not redesigning your entire network on the access. So basically, this draft is kind of trying to provide a simple solution, a seamless solution to make that happen. And next slide, please. So just a little background, what we did here is that back in the days, we tried to come up with a new signaling, which was just sending the PIM joins and prunes from the ingress BBR to the, from the egress BBR to the ingress BBR, which are the BIER boundary routers. And what happened was what we came up with, the AD at the time, we kind of mentioned that, well, this looks like a draft of its own. And then PIM Lite was kind of born. So that PIM Lite has gone through the evolution stage, and it has grown up to RFC 9739. So basically what I did is I incorporated RFC 9739, and it was very simple to incorporate that RFC into this draft. Everything else is the same from technical perspective. Next slide. Yeah, next slide. So there are some open discussions. I know there was a discussion between Stig, Jeffrey, and myself, and with regard to the join prune attribute. So right now we use the join prune attribute to send a bunch of information from the EBBR to IBBR, and those information is the subdomain, BFR ID, and some other information that you can read in the draft. There was a valid point that some of this information can be found in the BIER header. So why we are kind of duplicating the information in the join prune attribute and in the BIER header. And there was a question that if there's an implementation of this draft, how it's done. And I did respond, but I lied. The implementation that we have in Nokia actually does use the join prune attribute. The reason for that is we found it simpler to send the information from the data path all the way up to the CPU, and we get rid of the BIER header. So when that information goes all the way up to the CPU, we don't need to insert like a fabric header or any extra new header based on the BIER header to the CPU. The information is already included in the PDU, and that way we just strip the BIER header and we send it directly to the CPU. So from implementation point of view, it seems like it's easier because as soon as the packet comes in, we realize it's PIM light. We strip the BIER header, and whatever goes up into the CPU has all the information that is needed. My suggestion is still is to keep the join prune attribute because of that simpler implementation. Who knows what happens in the data path? Different data paths might be not capable of copying information from the BIER header into the CPU. Sorry, into some kind of a header before you send the PDU up to the CPU. And one of the examples is Broadcom chips, like a J2C+. I don't think anybody has an implementation of BIER on J2C+. So would it be risky if we take it away? But I mean, open to discussion. Jeffrey.
Yeah, indeed, the need for the JP attributes is the open question now. Thanks for Torres to bring it up last time. After some thinking, I'm actually thinking that by default, we really don't need it. The BIER header is lost before it gets to our routing engine part, the control plane. Initially, we thought that we need that information, but now I'm thinking that we don't really need that information for the regular cases. There are some special situations. I think Ice mentioned, not Ice, and Stig mentioned that, for example, if you have different BIER prefixes for different subdomains, in that case, you may need it, but I don't think that's a norm. So I would like to see that by default, we don't need that JP. And special situations, we can use JP, things like that. So indeed, at this time, it's mainly the offline discussions among the co-authors. We at a certain point in time, we should bring this to our working group. Yeah.
Yeah, I mean,
by the way, so in the MLDP case, we actually don't use that at all.
So I mean, we made the argument. I think the cautious thing to do is to check the security considerations, right? So there's always the IP header that you're trusting in terms of, you're getting a PIM join. We have 20, 30 years of experience how to trust or not to trust the sender IP address, and then the sender is the following BFER, and that basically means I can assign the bit. Now I have the additional attribute. So does it change anything to the trust model? What the information that I'm getting, right? I mean, the service providers course and all the protocols we have, whether it's BGP or something else, it's all a lot of hand waving on security, but you may get the question, right? So I'm not going to ask it, but there is additional information. What's the trust issue with it?
Yeah, I mean, again, the only thing I want to put in the table is the implementation. We found it very difficult to, on the data pad, to copy paste the different fields of the BIER header into a proprietary header on top of the PIM PDU. And then when you send up, where do you put that proprietary header, right? So imagine now you need to put the SD BFR ID from the data path, and now you need to put it in a bunch of bytes, right, in front of the PIM PDU. Do you put it in front? It becomes very implementation specific, right? Because you're extracting information and your implementation has to put it in the front, in the middle, or somewhere. So the question becomes, if you put it in the front, then you need to go do a bunch of implementation up in the CPU saying that the first, whatever, 6 byte or whatever they are, it is proprietary, which is the subdomain, BFR ID, etc. As of now, having this join prune a specific attribute for the BIER, it just makes it a cleaner implementation. That's the only feedback I can give.
Yeah. Okay. Yeah, Stig Venas. Yeah, at least when I was long ago working on this IGMP MLD overlay, we have this BIER draft on that. I found that it was difficult to get that information from the BIER header. So that's why we proposed in that draft to have like some IGMP extension to provide this this information, right? So it's kind of the same concept. So I think it is easier. One issue is, from security point of view, I don't know if it's serious or not, but should you trust that the information in that attribute matches what the sender, what is in the BIER header? Or is it good in some ways to have the flexibility that the join might be in one subdomain while the data might actually go somewhere else, kind of?
Well, I mean, to that point, in the PIM Lite, for the security part, we said that you can actually authenticate the PIM Lite via IPsec AH header, right?
Yeah.
So same like PIM.
Yeah, so if you can trust the contents of the join, basically, like say the S,G and so on, then you could trust this part as well, I would say.
Yeah, I thought for the case where you don't have multiple bits in different subdomains assigned to the same BFER, that it would be good enough just to use the BFR ID IP address as the source address for the PIM join that you're sending to the BFR. And from that, the BFR in the control plane just determines the SD and the bit, right? So
that's true, but to give you an example, like the support that we have for BIER is multi-instance, so we can
but I think that's what Jeffrey was saying, right? For the simple case, it would be good enough to use the IP address from the header. For the more complex case, if you don't have multiple BFR IDs, one for every SD, SI bit combination. If you don't have a mapping to a different IP address, right? But they're all mapped to the same IP address, then you need the join. Then you need the new attribute.
So I completely agree with you that you can get the information from BIER header. My point being
No, wait a second. So I'm confused by that. I don't think BIER header. I'm talking about the IP encapsulation header. You have a source and IP destination address in the IP header that you're sending, right?
Indeed, in the simple situations, you do not need those BIER information at all. All you need is that source routers, the IBBR's BIER prefix. That's the only thing you need. And then you can get that from PIM package.
Oh, okay. So you're saying from the BIER routing table, you can get that information based on the bit on the header.
The BFR prefix is your source IP address, and from that, in your normal, BIFT in the table, you can derive the BIER information, the bit that you then on the BFR need to put together.
Okay.
For the
so just to make sure, right now the concern with adding the join prune attribute is security reasons.
that's not the main concern. Really, that's you do not need the information from the JP attribute. But then I think the Torres' point is that if you do add that, and then you have to worry about.
Yeah, it may be inconsistent, right? So now which of the two are you trusting, right? So all I'm saying is we shouldn't add something that's unnecessary, because one of the things we're trying to do here is to show how nice and simple the whole thing is compared to BGP, for example. And, you know, if we don't have these attributes, it of course looks a lot more simple and elegant.
Okay. And when there is actually, like, we need a subdomain because there are multiple instances, then you guys are suggesting optionally we add?
Well,
when
or
it's,
basically the
truly
deployment.
needed, then.
Yeah. It really depends, right? So in IPv6, it's very simple that, you know, for every subdomain, you have a different BFR prefix, a different address, right? Because you may have routing policies and others that differ between the different domains. So if you, as soon as you give the same BFR prefix to them, then all other related things may also become more difficult, because now you can't distinguish them at the IP level anymore. You always need to carry everywhere, you know, your SD and everything. So it's a lot easier to have different IP prefixes. Maybe if you have an IPv4 core, then you don't have these addresses.
I mean, okay, we can look at the implementation one more time and see if we can get rid of it. But I mean, I guess the end question becomes, if from implementation point of view, this becomes difficult, then what is the next step? Okay, so I'm guessing we are still going to the working group for those answers, or for the answers of what we actually want to do with that PIM join prune?
Yeah, so basically want to, so far beside the discussion here, it's mainly offline discussion,
Okay.
but I'll bring it up
Okay.
in an email to the working group.
Okay,
Just
thanks.
some.
For me, I would say I don't do implementation. I think implementation always beats everything else. I just haven't found a good argument why the implementation should be an issue. So as soon as you see an issue.
I don't know, man. That's the part that the hardware guys have to answer. I have no idea. All right, so I'm not gonna go into this one. The Shepherd review was done. I mean, you guys can read the slides. I'm gonna save some time here. The Shepherd review was done. I think everything is complete on this one. I guess my only question is, what is next? I think we did the last call on everything. What are we gonna do next with this draft? Are we, sorry, go ahead.
Actually, there is two things with this now after I recently reviewed it. One is about whether it's a downstream or upstream assignable in we use a DCB case. It's related to our next discussion. The other point is that I don't think we need that interface attribute to include the BIER information either.
Yeah, I think it was the
Yeah,
same
we'll
idea.
we'll follow up on that one.
Okay. All right. So let's go to the next one, the fun one.
So Tony, do you have any comments?
Yeah, I quickly chime in. And it's related to the previous presentation. So yes, implementation beats everything. So guys, chew it out on the mailing lists, okay, and make a decision after you know that stuff can be implemented. It can be implemented, you know, in a way that all the vendors can support. No rush there. The other observation, I read the PIM-LIDE, the 9.7, whatever, 3 something. And the one thing that struck me that the whole DR election thing has been kind of punted, okay, on multiple ingress. So it basically says either you have a PIM adjacency PIM session between all those guys and they kind of figure out, or otherwise it's just IGP where they somehow have to figure out who is reachable and then do some tie breaking. So are we happy with that? It's like the final state from BIER perspective. I'm asking, is that good enough?
Sorry, I didn't 100% follow the question.
So, I mean, we were talking about this generic, you know, election mechanism when you have multiple ingress into the BIER cloud, so you don't end up replicating packets, right? In case of the beam signaling.
Did you get the question?
What's the problem with my mic? Or what?
It's becoming a little bit jumbled for me, but I'm getting old, so I don't know, maybe it's my hearing.
Okay.
We didn't seem to talk about that. Maybe it's something related to the,
What was the question, though? Can you repeat the question?
So the question is, you know, when I read the
Well,
937,
it seems like Jeffrey got it. Did you get the question?
well, I hope I got the question. I think he's talking about when there is a conflicting information, what do you do, right?
Oh, between the
No,
BIER
no,
header
no.
and the assert?
no, not at all, not at all. I'm talking about the BIER election. When you have multiple, would you call them IBBR or something like that in light? When you have multiple pins hooked up into a BIER cloud, so you may end up with multicast replication, right? You have to decide who sends the multicast packet into the BIER cloud. Correct?
Oh, that one, I don't think we talked about it here today.
Yes, but it will be related to the draft, right? Because now we're relying on the PIM Lite draft, and there, or the RFC, and the PIM Lite basically kind of punted the question. I said, if you have this problem, you either need to really a PIM session between those ingress points, or otherwise you just use IGP to tie break on the IP address or some such thing. And my question is, are we from the BIER perspective fine with that? Is for us with that the problem resolved, or do we need to do something more? That was the question, you know.
Yes, Stig here. I think I understood the question. So the problem is, at least with things like, say, the IGMP overlay, is that we are not joining to one particular BIER router. We are just saying we want to receive traffic for this source, right? And then you need to have some kind of DF election or forwarder election or something, like which BIER router should actually be the forwarder. But with the PIM solution, you do RPF lookup, right? You are joining to one specific BIER router. So I don't think it's an issue with PIM overlay.
I don't think we have an issue there, actually. Let's say that some IBBR choose EBBR1 and some others choose EBBR2. Then EBBR1 and 2, they can both send traffic, but the traffic will, from EBBR1 will only reach to the set of
Right.
IBBRs.
No, I agree. So what I'm trying to say is I don't think it's an issue for the PIM overlay.
Okay, I don't think we fully communicated because the RFC 937 actually talks about this issue and how it's supposed to be resolved. But I take it as that. Okay, thanks.
Yeah, I guess we first need to make sure we understand what we are talking about.
I
Well,
paste this section into the chat, okay?
Yeah.
Let's move on.
Okay, sounds good. So we're going to take this one to the working group as well, discussion. Apparently there's 2 items open. Sorry, go ahead. No, I think that's, I don't think, nothing has changed. All right, the ENTC, that was a fun one. Next one, please. So what did we test? Basically, there were 3 vendors. It was Nokia, Juniper, and Huawei, and IXIA there. And thank God for IXIA because they really helped us debugging some of this stuff. So the first thing we tried to bring up is just unicast VPN with SRI-SIS. The reason for that is obviously we want to resolve the source on each next generation MVPN. Then we brought up the BIER underlay with ISIS extensions. And eventually we brought up NGN VPN using, as you see in the code, some procedures of RFC 9573. And I explain why I have that in the code, in codes. Next slide, please. So here's the topology. Basically, we had the triangle, and BIER was running between everyone, ISIS, with the unicast SRI-SIS for the VPRN for the VPN services. We created NG and VPN, and we only brought up inclusive PIMCs, the IPIMCs. So we were advertising from BGP point of view, address family, NVPN, IPv4, and VPN, IPv4 address family. So the role of the IEXIA here just was to send IGMP, to be an IGMP receiver and be a source. So it had to be both roles for every single router. When it was the receiver, it was sending IGMP joins or prunes. And when it was the source, it was using the PIM signaling to forward that join and prune from NG and VPN all the way to the source of the IEXIA. Next slide, please. So from configuration point of view, I think one thing we kind of need to understand here is that on Nokia side, when it comes to the RFC 9573, we only configure that service label, if you will, that label in the provider tunnel attribute. We only program it as a static label. So meaning that we go under the next generation MVPN service, and we say that here's label X that you need to advertise on the PTA with BGP MVPN family address to the other end. We do not follow, so that's portion of the RFC 9573. We do not do the whole shebang in the RFC 9573. So this is why our signaling, even though we are using the DCB label, it's still doing same thing as RFC 8556, which is really upstream assigned label. The only thing that we do is when the label comes in, we compare the label in the PTA with what's configured on the router. And if they don't match, we don't install the label and we don't bring up the NG and VPN. This is something that we had talked previously for the interrupt, and it seems like it was understood by everybody, and signaling did come up, just to be clear. When we did this implementation, we brought up the overlay NG and VPN with Huawei, and we brought it up with Juniper as well. So everything came up, no problem. Where the problem came, next slide, please. And I wouldn't say problem, where a little bit of disagreement came between the routers is the BIER next header protocol. So since Nokia and Huawei were using upstream assign, we were putting value 2 in the next protocol of BIER, while Juniper, that was supporting the RFC fully, they were putting downstream assign label, and they were putting value 1 in the BIER next header. And to my surprise, the coders, they did a very good job, and they were saying if the value of the next protocol doesn't match what I support, discard the packet. It took us a good while to figure out why these packets were discarding, and eventually what gave it away was IEXIA. We tried, they had the BIER for the Wireshark, they had the BIER PCAP, they could actually decode it, and we saw that when the protocol, next protocol was 2, IEXIA was decoding the BIER packet perfectly, showing that the next header is IP with the SG and going all the way to the payload. When the next protocol was 1, we were seeing that IEXIA is not decoding it correctly, and that's what gave it away. We are like, well, how come it's not decoding correctly? And we start talking to IEXIA, and they went through the code, and they're like, oh, if the protocol is 1, then we are not falling through, and that kind of gave the whole thing away, and we realized what the problem is. So next slide, please. So yeah, I already explained this. Sorry, maybe next slide. You can read it on your leisure. So as I said, the interrupt issue is really the next protocol. Again, as I said, Nokia is still using the RFC 8556, and I explained the implementation. But the question in my head that I still haven't been able to answer is, why is it that in BIER RFC, we really have two protocols for MPLS next header? We have upstream assign, downstream assign. And that complexity, as we are seeing in this implementation, is creating an interrupt issue. And I'm sure as we go forward with EVPNs or whatever other type of implementation that comes, in the future with BIER, there will be confusion here because of those two protocols. So I don't know if you want to simplify that. To me, it's just seeing the fact that signaling is coming up with either one of those protocols. It kind of says that maybe we can just go to one protocol and be done with it. But I mean, it's open to discussion. So anyway, whatever we decide, however we want to figure out how to resolve this issue, we need to go back in there in ENTC next year. And I think that was the last problem before we could have fully MVPN, next generation MVPN, interrupt between Huawei, Juniper, Nokia, and even IETF. They were able to bring up MVPN fully with all the vendors. So it's really in good shape. We just have that little hiccup. And I think that's the end of my presentation.
Okay.
Yeah, Thomas. Yeah, thank you very much. So that's lovely to see running code, and great that you could identify and make it actually work better. So now let me play the totally paranoid conspiracy theorist and say that in this topology, I cannot easily believe that BIER bit string was used for replication, right? So if you can on the next round, right? I understand you only have 3 vendors, but if there was a single P BFR in the middle, right, that gets 1 packet and sends out 2 packet, and the only stuff he has is BIER and nothing else, because in this case, this could all be implemented with ingress replication, right? The 2 copies you're sending out. You're sending out
no. So we tested the scenario.
Of course, it's as I said, it's paranoia, right? So, but it's just from the physical topology, with this physical topology, you can simply show here's a P node that doesn't have any of this, necessarily control plane stuff, so that it could do ingress replication. With this topology that you have, there could be ingress replication happening under the hood, and the whole BIER header is ignored. I'm just saying, right? It's paranoia. But if you really want to show the most simple topology where BIER must be used, then it's in the middle. It's not a triangle, but it's basically 3 links going into a single core BFR. That is not a BFIR or BFER. That's what the conspiracy theorist says.
Okay. Can I interject?
Yeah, of course.
Oh, thank you. So first thing you need to realize is when you go to the ENTC, I got a colleague over there. He's hugging all the routers. So I don't have all the hardware that we can. But to put your mind at ease, last year we did BIER interrupt. So if you go to the last year, and we did have a P router in the middle, and nobody did ingress replication, and we were pumping BIER packet from IETF to a P router, and the P router was Nokia. At least Nokia was doing its job.
Good. No, I must say, did you folks give a report on that? I think.
All right, wonderful. Let's go to the problem now.
Yeah. No. I mean,
next protocol 1 or 2. Hands up for 1, hands up for 2.
Sorry, what?
The actual problem here is the downstream assign label versus upstream. That's what the interrupt issue here is. And next year, by the way, I mean, all the joking aside, next year we will put the P router in the middle. The reason that this year, we were going to do it this year too, with the P router in the middle. The reason that we didn't do it is when we hit this interrupt issue, we didn't feel that it's going to be beneficial to go to the next step, right? So on the last day of ENTC, if this whole thing was successful, we were going to put a Juniper in the middle, and we were going to put a Nokia in the middle as a P router to make this happen. The entire idea was to make sure that the signaling is coming up and we are passing traffic to go to the next complicated setup, which is really a star, right? So a P router with 3 routers on the side. So yeah, your point well taken, all the joking aside.
Yeah, so I don't fully remember in the context of BIER, right? Obviously, I think we all understand what the upstream and the downstream assignment labels are in MPLS. I might even have an RFC with that to my name, but
I have a whole slide prepared for this.
Okay.
So I can, yeah. So thank you for this
All right,
report.
thank you.
So I can confidently say, as the main author of RFC 9573, that it needs to be downstream assigned label. And that's one thing. And then another thing about your point, why bother with 9573 since we already have 8556? Can we just have one protocol? That's a good question. And also, I have prepared to answer that question in my slide deck.
Okay,
So,
perfect.
yeah, okay. So during the offline discussions, I explain, actually, so while trying to explain why it needs to be a downstream assigned label, and it turns out that RFC 5331 itself, which defines upstream assigned label and downstream assigned label, does not cover the situation we're talking about. That's why I also prepared another slide deck to be discussed in the MPLS working group. That has been added to the agenda. Today, I'm just going to focus on this one, why we bother with this DCB label approach and why it needs to be downstream assigned. Next slide, please. I will give quite some background here. So first up with the name terminology, PMSI, Provider Multicast Service Interface. It's a logical interface that enables sending the customer multicast traffic to a set of PEs. So in the BGP, MAP, and RFC 6514, it says that if you are using a P2MP tunnel for multiple purposes, for example, if you use the same P2MP tunnel for multiple VPNs, you need to use an upstream assigned label to identify that the packet is for which particular PMSI. So when you do this, it's called tunnel aggregation. And that upstream assigned label is advertised in the PIN-Z routes tunnel attribute, PTA. That label is first imposed, and then the P2MP tunnel label is imposed. This label is used to identify the PMSI, but this PMSI could be really just at the entire VPN level. It could be at a per PMSI level. So it can be used on the egress to just identify the VPN. So it's like the per VRF table label. So you get that label, you find the corresponding VPN and VRF and do the lookup there. That's one purpose. Another purpose is that when you have the tunnel segmentation situation, you can actually use that label to do the label switching without doing the IP lookup. So that's where the label needs to be at the PMSI level. Now, Why the label needs to be upstream assigned? That's because when you do the P2MP tunnel, the ingress sends in one copy. That copy is received by all the tunnel leaves. So all the tunnel leaves will get the same label, and that same label is from the allocated by the ingress. So it's called upstream assigned label, and that label is installed in a label forwarding table that is specific for that ingress, and so we call it context-specific LFIB here. So that's just the upstream assigned label usage in the MVPN. So also the same concept applies to EVPN as well. It's just now that upstream assigned label can be used to identify a broadcast domain versus VPN in the IP VPN case, or you could also identify Ethernet segment. Now, BIER can be considered as a P2MP tunnel. So if we are only talking about MLDP P2MP tunnel, then the tunnel aggregation, the use of tunnel aggregation is optional, and so far it's not widely used. But when you use BIER, then the tunnel aggregation is mandatory because the BIER underlay is inherently shared for all the VPNs or the PMZs. So RFC 8556, which is the first specification that talks about BIER used for MAPM, and RFC 9624 that specifies BIER for EVPN, they do indeed use upstream assigned labels. Those are actually complete solutions. You can use those upstream assigned labels to do all you need. But why did we bother with another RFC 9573 using the DCB labels, which are really downstream assigned labels? Now I'm trying to explain it, what it is and why do we want to use it. So we already talked about that when we use upstream assigned labels, those labels need to be installed in a context-specific label forwarding table on the egress PE. And so that brings the complexity and scaling issues. So on the complexity side, whenever you get a packet, you need to first identify the source of that packet, and then you find the corresponding context-specific LFIB to do the next label lookup. So in the control plane, that context for that context-specific LFIB is typically the ingress PE's IP address. In the forwarding plane, depending on the tunnel technology, so if you are doing a P2MP tunnel, for example, MLDP, then the context is derived from the incoming label, because that label is specific for a particular tunnel, which is specific for a particular tunnel ingress. So from that incoming base tunnel label, you know the context-specific LFIB. In the BIER case, the BIER header contains the information that will lead to that context-specific LFIB. So we do have to use those information in the packet to identify the LFIB to do the next lookup. So that's doable. It's just some complexity. But the major problem here is a scaling issue that we want to avoid. So consider that you have a MVPN or EVPN deployment that has 1,001 PEs, and each PE has 1,000 VPNs or broadcast domains or Ethernet segments. Now, each ingress PE will need to allocate 1,000 labels to identify those VPNs or broadcast domains. For example, PE1 allocate label 1001 through 200, 2000. PE2 allocates 2001 through 3000, so on and so forth, from their own label space. Now, when the egress PE gets the signaling, for each ingress PE's address label, it needs to put that label into a corresponding label LFIP specific for that ingress PE. So now, each egress PE needs to maintain 1,000 LFIPs, and each LFIP contains 1,000 labels. You put that together, it's 1 million label to identify those VPNs or broadcast domains. So clearly, this is not going to scale. To solve this problem, we introduced this concept of DCB label, or domain-wide common block. I suppose people are familiar with the sRGB labels. This is the same thing. We call it a DCB with a new name because we don't want to tie this to SR. This concept and this solution applies to non-SR network as well. So it's different name, but same concept. And now the PNZ route we talked about earlier, now advertise a label carrying a flag, we call it a DCB flag. That flag will cause the label to be installed in the default LFIP on the egress router. And the incoming package needs to be looked up in that default LFIP. Because it's installed into the default LFIP and looked up in the default LFIP, that's why it needs to be downstream assigned. That's why in the BIER header, the protocol needs to be set to 1. Now, we do have a specification issue here that's in the RFC 9573, we said that this DCB is from the default label space, but we didn't explicitly call out that this is downstream assigned and the BIER header need to set the protocol field to 1. So that's the problem that we need to fix. That's easy. It's just, we could do it through a errata, or you could do a very quick, short RFC. But now, then someone reading that this RFC will say that, wait a minute, if I follow the RFC 5331, I will get a different conclusion that this label is indeed upstream assigned. So that's indeed a problem that I want to discuss in the MPLS working group. So in the MPLS session, it's already added to the agenda. I believe that we need to clarify that this label in the DCB label is indeed a downstream assigned label. So now, more clarifications for this RFC 9573. I think I can skip this one. I think I can skip all these slides here, but I want to emphasize, point out why this solve this scaling problem is because now the all the PEs are provisioned consistently with the same label for one particular VPN. So let's say you have a VPN, we call it the VPN 1. Then on all your 1,000 PEs, they all use label 1,000. They use label 1,000 to send, and they use label 1,000 to receive. So that label is put into the default LFIP, and that's it. If you have 1,000 VPNs, you need 1,000 label in the default LFIP. So that's how the scaling issue is addressed, and that's why it needs to be the downstream assigned label. I think I'll stop here for now.
Yeah. I just quickly tried to look that up, so I have.
Please speak your name and company.
My name. Tall is a future way. So no, I wasn't aware of these details in 9573. So just off the top of my mind, it sounds more like as if these DCP are global labels, right? So they need to be coordinated. So I'm completely confused by the term downstream label, which is a pure unicast concept where, you know, never two routers would agree on something like that. And with BIER packets being multicasted, I think downstream label doesn't make sense at all, right? So, I mean, if that would be called, you know, the code point would be called for global label or DCP labels, that would be lovely, but that's just terminology, I guess, right?
Indeed. So the key, the real key is that where your label is going to be installed and where your label is going to be looked up. But at this time, the only term related to that concept is upstream assigned and downstream assigned. And in the BIER encapsulation RFC, we will only say that if it's downstream assigned, you set the protocol field to 1. If it's upstream assigned, you set protocol field to 2. What really needs to happen is that if the next label following the BIER header needs to be looked up in the default LFIB, then protocol field should be set to 1. Otherwise, it should be set to 2.
So I think whoever came up with the original code point table and said downstream label didn't really think about, you know, not even thinking about it. There isn't a single case. It's always multicast, so it cannot be. So it would have to be default MPLS table or default FIB or so. So maybe just change the name of the thing, right? In
That's
the BIER
exactly
registry, yeah.
That's exactly why we are going to discuss this in the MPLS group. The slide that we accidentally showed earlier is the slide I prepared for the MPLS working group. You can get a preview and you can come to the MPLS session and we can discuss that. Yes.
Yeah, Human Nokia. So I listened to this presentation. It still didn't answer any of my questions. I'm still very confused that what is the difference of on the data path? What is the difference? Because BIER is data path. Let's face it, right? It is not control plane. So when it comes to the data path, I don't understand why the next protocol in the BIER has to be downstream or upstream. To me, a label is a label. That label is identifying a verb to go to, and I couldn't care less whether that's downstream assigned or upstream assigned. The purpose of that label is to identify the verb that when I get rid of the BIER header, I shoot the packet to that verb, and that verb looks at the SG and makes the decision making of where's the OIF.
Right. Yeah, that label needs to be looked up in a label forwarding table.
Incoming label, yeah. So
right.
What you're talking about is implementation. Maybe Juniper implementation is 2. For Nokia is 1 single incoming label. I don't care whether it's upstream assigned or downstream assigned. This is implementation that you're going with.
And I think my name is actually on that, you know, upstream and downstream label stuff. So, but it's been a while, 2008, right? So, the point was the upstream label was actually something that was meant to be layer 2 multicasted, right? So in the same way that now you've got this crazy network-wide multicast called BIER, but it's the same thing. And the point is that if you have multiple interfaces, right, different upstream neighbors on different Ethernet interfaces would give the same label to you. So that label lookup, that's what Jeffrey was trying to explain, isn't in a single global label table like the DCB, but you need to have it in a context label table that could be different for each, you know, BIER subdomain or each Ethernet interface, whatever it is, right? It's a totally different, you know, reusable label space. So it's a lot more powerful, but it's also a lot more expensive. So if you want to scale it, you do the DCP. So that difference makes a lot of sense.
So, okay, I get it that you're saying that you want to have a label space per verb or something like that, but I can argue with the same thing. As technology evolves, I can have a single pool of labels that I use for all my PIMSs, upstream assigned, so PIMSs. So basically, let's say that if I have 1 million upstream assigned PIMSs, right? And these million PIMSs are across 100 verbs, right? SPMSI and IPMSI, right? I will use 1 single label pool to assign 1 million labels each for a different PIMSI. I don't need to have a separate pool.
No, wait a second. I'm saying is, if it's upstream assigned label, you may get in the control plane from different routers for different purposes the same label, but you still need to be able to keep them apart. You would be getting BIER packets, in different contexts, whether it's different verbs, VPN or whatever, and they have the same upstream label. But now because it says upstream label, you're saying, well, I can't look them up in the same table. I know there is another, label 1000, so I need to do a lookup based on whatever other context I figure out. Like it came from this VRF, I have for this VRF now this 1 million labels. It came in from another VRF, I have exactly another table, and there can be exactly the same label. So that's based on the control protocol that you have. Whether that is, from some upstream label router did assign that label, and you can have another one and they can assign the same label, need to keep them apart. That is never a requirement for the downstream label, which is why it's more limited, right? So at some point in time, you're running out of it. You can't create a second instance for it.
Tony.
Let me chime in with a little bit wider perspective, okay? So first, because the lookup procedure looks different, it already indicates to you that those are two different beasts, although they look like the same label. But you could argue that if they are not overlapping, you could lose the distinction. Okay, I'm not talking about the specific problem you talk, whether you should be using one or two here. That is a convoluted thing. I just let it run. You guys are super expert here. But in terms of this upstream, downstream, losing the distinction, don't forget, I mean, this is all getting more and more fuzzy. The technology is finding more and more use cases. At a certain point in time, the downstream, the upstream may start to overlap as values. And if you lose this distinction, we may end up in a very difficult corner to resolve in terms of technology. So from my perspective, the upstream and downstream distinction is real, okay? And it may, for example, get entangled with all the L2, right? Some people start to build optimizations, and then the problem on the L2 multicast is real with the upstream stuff. So I would keep the distinction between the 1 and the 2 as an upstream and downstream. How the semantics fall out and what you decide in this specific case, that's more tactical. Thanks.
Okay, Zheng Bin from Huawei. In fact, I almost forgot the details about the MVP or like this one. But before I came to IETF, I discussed with my colleagues about the interoperability issues. In my opinion, the first, because that we can use a common DCB label to identify a VPN, BD, or ES. From this point of view, because this is a common label, it can be seen as this upstream allocated label, or it can be seen as this downstream label because they are same. But in fact, one point we think is important. We proposed for the working group to thinking is about the control plane, the procedure. Because we at the beginning we don't to distinguish this one, because that we have implemented this one based on the RFC this 6514, because that one is the upstream allocated context label. Because for that the RFC is not only the data plane, but it also has the control plane, the procedure. Yeah, because because we can use one common label for all the PEs. From the control plane, we can see that all the downstream, the receivers, to learn the label from the root and to keep the same. But if we, from the point of the control plane, if we think the label is the downstream allocated label, so which is the downstream, we have the many receivers. We have the many receivers because every receivers can be seen the downstream of the MVPN. So I wonder if we thinking in the control plane, so how to coordinate the label. Yeah, that's an important point for the thinking.
So that's why I think in this BIER, code point table, we should change the name from downstream to global or DCB, whatever the best term is, because the downstream label allocation, when we did multicast MPLS, that was purely when you transfer a multicast packet over a unicast encapsulated layer 2 encapsulation, right? When you unicast it from from an upstream router to a downstream router single. So then the downstream router could give the label, right? So, and that's never the case with BIER, right? Because BIER will always have more than one receiver potentially, so it can never be really downstream allocated, but any possible receiver, any single downstream can say, well, I need to put a label here from the magic global table, which the DCB is, and all the other routers have the same label allocation. So because it's a global label, everybody, it's more like a SID in the term of, SRMPLS, right? So everybody has the same consistent information about that. And that's why they picked downstream, because that was the only other code point that was available in BIER, yeah.
Right. Upstream assigned label concept does apply to multicast as well. And that's what RFC 6514 and RFC 8556 used. Now, for our BIER purposes, the existing signaling defined in 9573 still apply. The real key is that the terminology. Indeed, it's the terminology. It's not about who assigns label. It is about where the label is from, and where the label should be installed, and where the label should be looked up. And indeed, we can update the BIER encapsulation RFC to change the terminology from upstream to downstream, upstream downstream to where to do the lookup. Or I actually have that in the MPLS discussion slides. And another option is to just say that downstream assigned, including the downstream assigned or the downstream delegated or something like that. So basically, you change the meaning of the terminology, and therefore any RFC that use the old name does not have to be changed. That's another option. We don't have conclusion what we to do yet, but I think Torres, you and I agree that it's really about where the label is from, where the label is installed, and where the label is looked up, and that's the key.
Yeah. I think when the BIER table was done, they simply copied the two terms that were defined for no BIER MPLS label allocation and didn't think about that it didn't apply. So now we have a way to make it work, which is the global DCB table. So, and we use the free code point, so to speak, and let's ask the MPLS people what they think. Yeah.
Oh, Tony, do you have?
Folks, don't try to, hammer out all the details on the mic. Otherwise, it will be endless. Watch the agenda. If you have more stuff to push through, then, we need to focus on the presentations here and not trying to resolve every single details. Mailing lists are for that, and there is still, all the MPLS input that you need. Thanks.
Yeah, Human Nokia. I think there is some stuff we need to clarify here on face-to-face. I guess one question is that this DCBS stuff, I think we all agree you can configure it statically too. So if you configure it as we saw in the ENTC, if you configure it statically, you can still use upstream to signal the label. So again, I kind of agree that, maybe we need global label added to BIER rather than this downstream or upstream, because I think if you go down this downstream, upstream, depending on different implementation, how Nokia does it, how Huawei does it, how Juniper does it, we are never going to come to agreement.
I want to make 2 points here. One is that we agree that we either need to change the BIER encapsulation RFC to stop saying upstream, downstream assigned label, or we change the meaning of downstream, upstream assigned label. That needs to be done, and we will discuss more in the MPLS working group. That is one thing. Another thing is that regarding your static label, label from this default label space, that still needs to be treated as the, if we use the old term, then it's still a downstream assigned label, or we change it to mean that, yeah, that label needs to be installed in the default LFIP and looked up there.
Well,
We
that's the entire confusion here, I think, Jeffrey, because as I said, from implementation point of view, we are using what we call upstream, right? And a static label, and it's working. So, I mean, there is no way to bluff that, hey, no, you're not using RFC 85, whatever it is, that is upstream, and it's not working. The whole thing is working with RFC 85, whatever, which is upstream. You need to keep that in mind.
It's working for the wrong reason. And it also defeats the purpose of the 9573. We can talk more offline.
So last 20 minutes, Torres. Oh, thank you.
Yeah, the absent chair wanted to remind us that we have 10-year anniversary this time around for the working group, right?
Yes, nice t-shirts as well. I got mine. Wear them proudly. So
this time, I'm just being a pain as a reviewer, not as an author. So I wanted to first explain why. Wow, this is far away for your glasses. So already paying the second time for the poor AD after one other, and the reason really being that this topic here, FRR, is something that I had painful experiences in the past, since we did multicast and first the whole RSVP-TE point to multipoint, where we couldn't even get node protection. Then we were trying to do node protection with PIM, and we only got to the way too convoluted pattern stage. Then recently there was this MOFR TI, MOFR and PIM, which kind of doesn't really work. And so then we tried to do the same thing with BIER-TE, where it also didn't work. So it's basically node protection with multicast, other than normal MOFR, which is working fine in dual plane networks. We could never find something working, and I kind of never had a look at the FRR for BIER. And before I was asked to review it for routing directorate. And so now going through this, I'll have to say that this is kind of the best invention since sliced bread, or it is sliced bread for BIER, because so many customers have been adamant about sub 50 millisecond protection for multicast services, and we've always been struggling in making resilience for multicast work that well. And the best thing we could get sub 50 millisecond protection was MOFR, but you needed specific topologies to make that work. Or something really link protection with RSVP-TE point to multipoint. And with BIER, it's really extremely elegant and great because of the way that BIER works with a simple bit string, right? So there definitely is the interesting question: how easy or how good could it be implemented in BIER hardware? So I'd be very interested to learn about that. But so I'd really would love this to be very well represented to customers, so that maybe this is the thing that's missing for them to, be interested in BIER, because this is something none of the other, prior multicast technologies can support. But unfortunately, the document itself has a lot of textual downsides. So now to take the last slide ahead, I was talking with Mike, as I think now the editor of the document. And so they're going to add whatever of the small items I was providing in my feedback, and then I think let's ask next IETF if more people think it would make sense to have a second revision, kind of after this first RFC is out, that is a lot more inclusive and better, and hopefully I could even help to write that, because I think, you know, the technology is certainly worth it, but that I think would also depend on some of the hardware platforms to come back and say whether this is, you know, actually well feasible. I haven't even talked with Michael Ment, who's also on the board, what they've done on P4. So, but yeah, it looks doable, right? So we can quickly go just through the high level things that are, you know, really not well done in the document. Yeah, so the kind of, there is no good marketing, why this is unique and great because of the node protection. And well, the whole point is because you have a bit string, right? You just need to send the packet somehow around the broken node, and wherever you leave it out, the bit string again will do the necessary replication, right? It doesn't have to come out at a particular place, which gives you also a lot of options to optimize the whole thing, right? And there's almost no interop issue, right? So if you can assume that you a tunneled BIER packet over some, you know, unicast tunnel will be decapsulated and put back into BIER, you have, you know, you can start just implementing it without any protocol stuff, right? So that makes it ideal for incremental deployment. Then, of course, also the whole document doesn't mention MPLS. It sounds almost as if this is only applicable to BIER in an IP network, which I think we've not done at all so far, right? So, you know, anybody interested in BIER in unicast MPLS networks, because obviously the backup tunnels need to have some unicast forwarding plane. In many of these networks, that would be MPLS, or rather, hopefully, SR-MPLS. And so that is something that would probably be, you know, if this wants to be sold to customers, be added, the MPLS explanation. There is some type of classification there, FRR-based and tunnel-based. And I think there is one big difference in these two things that isn't really well said. And that is, in one very simple case, you don't need to do anything new in BIER, which is if you are doing tunnel protection through an existing MPLS backup tunnel, you simply use that as an adjacency. And so no work in BIER at all. That's not very interesting, but it's also a nice starting point. I'm not sure if some implementations may already be using that. So that would be one way to say that's kind of a pre-existing unicast tunnel. There is one very big question mark that makes things a lot more complicated to explain, which I'm not sure whether they have actually been implemented at all. So that was a question to the working group, and that's kind of this partial deployment, right? So ICE did a great job in the BIER architecture to outline in a way that I think only experts may understand, is that you don't need to deploy BIER completely on every router in a topology, but you just throw BIER in some routers. And if you have really good, you know, algorithms to look into your IGP topology table, you'll find the next best feasible BIER neighbor. So, I would really love to know if that was implemented, because if that's implemented, it has a big impact on the text, makes the text more complicated, but also would support that case. If all the implementations are just working with, you know, automatically determined link neighbors, then that could be left away. So that's a big question mark. And then the explanations are really, you know, making the problem more convoluted than it needs to be, because there is this wonderful optimization that depending on whether the FRR entry is processed first in the sequential order or if it's processed second. So I was proposing how to make that simple to explain, which is that, you know, if you do the FRR stuff first, you are serving all the bits for, you know, your backup, but also all the bits to the neighbor you're sending it now. So you don't even need to make a second packet copy. If you're doing in the wrong order, you are sending 2 packet copies to the same neighbor, one that you would have sent to the neighbor anyhow, and the second one that's just the FRR packet, right? So this is probably a much easier way to explain that. And in the same way, the example really doesn't make it clear why and under which circumstances for node protection you ever need to send 2 or more packets. And that is simply because if the node fails, right, in this case, the PBFR, if that fails, then you're creating a form of partitioning, right? So basically to reach all the 4 BFER, you can't use a single tunnel because you can't get from a single exit point of the tunnel to all the 4 routers. Because that would again go through the broken node again. That's why you need to send 2 different copies. And then, you know, there is a pre-established terminology that all the FRR people in Unicast know. That was established through 7490. That's a P and Q space. And so I think we should be consistent and explain all this technology through, you know, really the same terminology as is used in Unicast, whether it's MPLS or IP FRR, and the document doesn't do that. And there are a lot of optimizations then, and we can even expand that terminology space. But that otherwise, I think, you know, the Unicast people wouldn't even understand this stuff very well. And then, yeah, because BIER is so flexible, there is also a lot of strategies that can be used to determine what the best possible backup tunnel is, because ultimately one single backup tunnel is an optimization over multiple Unicast backup tunnels. And so that's actually an NP-complete problem. And so there may be multiple different strategies. The only one strategy explained is probably one of the worst ones. Oops. 6. Yeah, so there is no mentioning of what to do in the case of ECMP in BIER, which is a basic procedure of the BIER architecture. So that's also, I think, reasonably easy to add. Quite some amount of text I was proposing a little bit. And then there are 2 possible BIFT implementations. I think it needs to be made clear that these are actually just, you know, templates, right? I don't think there is any need for any implementation to do it exactly that way. There may be others. But yeah, obviously, you know, the hardware feasibility is one of the most important part to move forward and see if there is interest in implementations. But so it would be useful to understand if maybe another example of how it could be done might help better with implementations. So yeah, so I mean, I'm really excited. I wish that vendors would see this as a great opportunity to, you know, make BIER more attractive to customers that have FRR for the Unicast side, and for their multicast service would also like to have sub 50 millisecond failover. Yeah, I'd say, you know, let's see that this RFC goes through with whatever minor changes is. It's informational, and if there's more interest, then to actually get to something that gets implemented and makes a really good story also for customers to pick it up. Let's talk about it more. Thank you. Any questions? Yep. No, the plan is this was part of routing directorate review, right? So Mike is going to look through, you know, my humongous big review is going to pick up the simple things. And then, I mean, I'm just routing directorate reviewer, right? I'm saying it's fine. It's informational. It's the first round, right? If anybody wants to see why a non-ideal document should go through, I can talk about the first version of BIM sparse mode RFC. And that it's not worse than that. You know, then I would like to hear implementers, right? So to look at, you know, hardware feasibility, talk with me if you're interested to brainstorm what could be done to make it hardware feasible. And then, you know, have, you know, the vendors that may be interested in have an opinion whether we should do a second round, which includes all these nice good things, right? Starting with the introduction section that, as good as possible, sells this as, you know, now BIER has sliced bread, right? So because, I mean, now we have been paying for such a long time when video delivery started with multicast, right? They all came with, we need sub 50 millisecond failover protection for multicast. And it was such a big pain because we didn't have it, right? And we tried to do everything we could. And then we told them sub-millisecond would be such a cool thing if either A, we could do it, or B, your bloody video application would even need it. It doesn't need it. Other applications of customers that haven't asked would actually need it, right? So basically having a multicast solution now that really has a cool sub-50 millisecond that works in every possible topology is really a cool, unique feature for node protection, of course, right? Link protection is easier, but I think it's a cool distinguishing feature of the BIER bitstring approach.
Tony, in the queue.
Yes. Hey, so first, Thomas, thank you for pounding on the stuff. Okay, anything that raises quality is good stuff. You make a lot of good points. So my point to the authors of, so let's first say BIER already has the sliced bread. If you run it with IGP underlay, you get the whole IGP protection stuff with all the bells and whistles, okay? Now, the document is, of course, just defined. We talked about that if IGP underlay is not used, which is a completely valid, deployment of BIER. I warned the FRR, the BIER FRR draft folks that there is no rush. It's a complex thing they're suggesting. There's no rush to publish it, but they had aspirations to put it in front of ISG. So we went ahead with the process. If you feel, that lots of your observations have to be addressed and the document changed, go ahead. I mean, it's between you and the editor. I will not step in and try to push the stuff forward. I think, again, it's a complex thing. It has a value, but they will benefit from implementation. A lot of those corner cases ironed out before it goes RFC. Okay? So I let you run the process, basically. And thanks again for, the thorough review. Thanks.
Yeah, so the sound is really terrible. I'm not sure I understood everything correctly, so excuse me if I didn't. Yeah, I mean, I'm saying, it doesn't make sense to hold this thing up unless we really see interest in implementation and feasibility in implementation. And even then, at that point in time, it might be easier to have a second round of the document that is, targeted for experimental or even standards track and not informational. So I think for what it's doing right now, doing the minor fix-ups should be fine. And yeah, let's really talk about feasibility of implementation and interest in implementation. And then make a choice whether we want to have a second round of the document, right?
Niels?
Yeah, Niels, Deutsche Telekom. First of all, just only not to the whole discussion, a side remark, just a side remark to the timings that were discussed here. As one of the operators with a large multicast deployment, we often already have a sub 5 milliseconds failover with already today methods like MOFR. Mm-hmm. The question is always for which cases. Mm-hmm. What are the cases that you look at? If you have an incident which is the most often failure for us, a fiber cut, then you have an instant interface down, and typically the large routers will switch over the MOFR within 5 milliseconds. Mm-hmm. So only very few packets are dropped. What is always much harder to detect and then to care for are the RIP failures. So the failures that happen 1 or 2 steps ahead, more into the network edge, from the edge, looked more into the network core. That's much harder to get, and from the complexity of recent router software architectures we see with at least 2 vendors, I can say that those times have gone up in the last couple of years in the deployment. That's what we see. And as operators, everything that is below, depends on implementation, but below 100 or 150 milliseconds is a huge gain already.
Thanks, Niels. So, I mean, we talked about this, and the reason, and that was good because I put it in the first slide, but just as a reminder to the rest of the audience, the reason why MOFR works for you is because your network has the dual plane topology, which makes it possible that you have the 2 copies of traffic already, arriving at the same point in time. So you do a local switch over, like, let's say, BIER ECMP would be able to do potentially, right? So, but this, of course, the benefit of this FRR over MOFR is when you have the arbitrary topology, because then, no other option really works as fast. Now, whether you also the problems that you just mentioned in terms of other routing problems can be discovered by a link failure notification. I'm not sure, so we can take that offline, right? But the normal FR thing is you recognize a link failure, you're assuming a node failure on the other side, and you're doing node protection, and that's basically the best possible case. That is possible with all the wonderful TI LFA in unicast, which is finally after, what is it, 17 years or so, as the whole, you know, LFA stuff has been working, and also now with unicast having both SR-MPLS and SRv6, right? So we do have the underlying unicast forwarding technology to do TI LFA. And that's exactly, of course, also the same tunneling that we would use for multicast. So, I mean, we couldn't have done it earlier without the unicast tunneling. So that's finally here. So it's a good point also to start talking about it. But the fact that it's actually so cool because it's unique to BIER and we can't do it with any of the other mechanisms, that, you know, feels to me like an, you know, underappreciated option to sell BIER.
Absolutely, and I didn't want to mess with that. I just wanted to say that the implementation complexity within the routers have gone up significantly.
Sure.
So everything that drives down timing is appreciated by operators.
Yeah.
Okay.
Okay, I brought myself since I'm on a queue. Sorry to hold you longer, but probably a naive question. So with this, all their bypass tunnels in the BIER, how it's managed bypassing their failure or bypassing their tunnel, their node that is in a bit string?
Sorry, please repeat. It's really terrible.
Yeah, so naive question. So with the bypass tunnels, if the downstream is the node that is indicated in a bit string, so bypassing it messes up all your bit string, right?
No, I mean, read through this. So this is an extension of the BIFT. So if your next hop that, you know, you're losing the link to, and you of course don't know whether the link is gone or the node is gone, so it's always in FR, whether it's unicast or now BIER, you're always making a configuration assumption, right? So I see, you know, the link goes away. What do I assume? Do I assume the link is gone and the node is still there, or do I assume the node is gone? When I do assume the node is gone, then obviously I would simply remove that bit from the bit string and don't even try to deliver directly to that node.
Okay.
So that's already in the draft.
We have
We're
run
running
out of
out
time.
of time.
Yeah.
Yeah.
So Tony, do you have any other comments?
Okay, so before we close the session, I want to sell some t-shirts. If you are a BIER fan for this 10-year-old
10-year-old
new technology, the mailing list has information on how to order it. It's okay.
Or even better, for the next 10 years, right? If you're an AD, you got one use for free, right? So, you know, just become an AD in the next 10 years for BIER, and you'll also get a free one in 10 years.
Yeah, thanks a lot for all the work. It was big push, very fundamental technology. Thanks for the face-to-face time. I hope people exchange ideas. You know, everything in detail, please take to the mailing list. The MPLS stuff will be quite interesting to see what will happen with the latest stuff. Until the next one, bye everyone.
So,
Bye.
See you in Madrid. Thanks, everyone.